In this video, we're going to be looking at bias detection and bias mitigation in artificial intelligence systems. Why do we need this? Because AI frameworks have been criticized heavily for biased decisions, and we need to have systems in place that could prevent unfair or unethical outcomes. And some of the advanced research techniques that they're focused on bias prevention and bias mitigation include fairness metrics, starting up with the development of comprehensive fairness metrics. That is the starting point. And research in this area is focused on developing and refining fairness metrics that can be applied across various domains. So metrics like demographic parity, equal outcomes across groups, equality of opportunity, equal true positive rates, and individual fairness. Similar individual treated similarity rates, for example, are under continuous refinement to better capture the fairness of AI systems. But how do you implement this in complex AI systems? Well, projects are examining these implications of metrics in systems such as credit scoring, hiring, and healthcare diagnostics. Those are the systems that we need more equitable outcomes. And the challenge is in balancing accuracy with fairness. So the stricter the adherence to fairness metrics, this can sometimes reduce the overall model performance. And if you look at data pre-processing, well, there are new and innovative techniques in data resampling and reweighting, which are over here. And advanced projects are exploring the more sophisticated metrics of data pre-processing to reduce bias. And this includes not just simple but resampling or reweighting techniques, but there are also more complex methods like synthetic data generation, where AI is used to create balanced data set that reflect a more diverse population. And then also we need to consider bias detection in data acquisition and curation. So research in this area is also focused on bias detection at the data acquisition at different stages. So we need to recognize that biases often originate from how data is collected and prepared. And this involves developing tools and protocols to identify and mitigate bias before the data is even fed into the AI model. And another thing to consider is algorithmic adjustments. So we need to integrate fairness constraints into model training. So cutting-edge research usually involves integrating fairness directly into the algorithmic training process. And this includes modifying the loss function or to penalize the unfair decisions, or to incorporate the fairness objectives alongside accuracy objectives in the model optimization. And how we can optimize for accuracy and then adjust to improve the fairness. And this includes techniques like model recalibration or the application of fairness-aware ensemble models. And finally, the fairness in complex models like deep learning, given their complexity and often opaque nature of models like deep neural networks, research is being conducted on how to effectively integrate fairness constraints in these models without significantly compromising their predictive power.